you practice it.
The diagram.
Those Frere models. If you remember the Frere models, it literally has in the center the main idea, and then if you look around it, there's practice problems. Hopefully you took notes on those things. Because I bring that up because someone in first walk was like, Mr. Kenny, I can do it when we're in small groups, but like when I have to start doing it on my own, that's when I would break down. That obviously is what we have to do on the test. You have to do it on your own. Okay, and then I asked him, I was like, have you done any practice all on your own? He was like, no. And I'm like, why not? He goes, well, I just look at the answers on the back. And I'm like, that's a bad decision. If you need to be able to do it on your own, you need to do some of the practice problems on your own. Now, if you're getting it wrong, that's not helpful. That's why the solutions are on the back to help you check yourself. You have a test on Monday. If you have not done those practice problems, then you need to start working on those practice problems. I cannot emphasize that enough. There are questions that go with every single thing that can be on the test in those check your understandings. And then I even, and I linked it in Schoology yesterday, if you looked at the assignment, the e-learning day assignment, which was just a self-study thing, but you were supposed to do that practice, and if you're getting answers wrong, I have recorded and uploaded just me working through problems and explaining how I got my information.
Was it those 3 videos?
Yes. What?
I clicked on one of them and I got off so quick.
Why?
Because, I don't know.
Didn't want to study? Or it was just too hard?
No, I did the like things
Okay.
on myself. But
Okay. But like the idea is if you are stuck on some of those problems, then and the solutions don't help you, then you can go watch the video and work through one of those problems watching the video. Pause the video, go try the next one, and then check yourself. And if you still got it wrong, go watch the video. The idea is that you have 3 or 4 levels of help outside this classroom to help you grow and learn. Now, we are going to go over some questions that you may have off of the proficiency scale first, and then after that, we are going to look at a couple of details from the demonstrated understanding. Does anyone see the remote? Found it. I don't know why y'all steal my remote and put it on my desk. Okay, so Unit 2A, identifying functions. This is one of the purple ones. Any of the foundation or the target that you need to ask questions about? Good. I'll take that as a yes. Damon, you good on all these foundation and target things? Okay, so I do got to ask this because Ms. Kowalski and I were blown away a little bit about this in first block. I need y'all to remember there's a difference between a mathematical representation and the 3 functions we have studied. What are the 3 types of functions we have studied? Quadratic, linear, and exponential. And what are the different ways we can see those 3 functions? What are the representations that show us those 3 functions? Tabular, or our tables, graphs, pictures, verbal, and algebraic. Do not forget there are 5 of them, 5 different ways we can represent those 3 functions. And they each have their own way to be able to recognize those 3 functions. Okay? And so consider those things. What do I look for in a table to help me know what type of function it is? The rate of change. The rate of change tells the full story in a table. But let's say you're not comfortable with the rate of change. 1, let's work on that. 2, what could you do if you're not comfortable with looking at the rate of change? You can make a graph out of those points, right? And then the shape of that graph tells you what type of function it is. We're going to look at the algebraic sum in a minute to help with those details. But please remember the difference between mathematical representations and things like that. Alright, as a quick recap, always pay attention to linear versus exponential. What is the equation for a linear function? Which there's multiple, but the main one we've studied. Y equals mx plus b. That's the equation. Now, do you remember the name of that equation? What is it?
Standard.
Not standard. There is a standard form. We've not studied it, but this is my standard form of a linear. Let me ask you this. Caleb, what does this thing stand for?
The slope?
That's the slope, right? So it's called the slope-intercept form. Remember, the name tells you literally what it is. You need the slope and you need the y-intercept, okay? So slope-intercept form, the name tells you everything. Because what is going on in a linear function? What makes it linear? So it's a line on a graph, but what makes that line a line? Constant additive rate of change. And how do I see the idea of repeated addition in this equation right here? How do I see the idea of repeated addition in that equation? N times x, right? Like we're multiplying because it's constantly and repeatedly adding. M times x is repeated addition. And so that constant additive rate of change is quite simply called slope. Don't forget that. It's going to come up in a second as we review some of these ideas. What was the equation for exponential then? A times b to the x. How do we know that that's exponential? Like what's that key detail? What about that exponent though? It has to be a what? Well, the exponent is not a constant factor. What is different about that and this? Which one of these is, so, which of these two is exponential?
The x.
They both have an x.
The x to the power of 2.
So this is the exponential?
Yes.
What do you're saying no, Jeremiah? Why no?
Are they both?
They are not. Only one of them is exponential. The one on the right? But you were saying no, the one on the left, why? So we don't know what the exponent is going to be. So what does that indicate? Repeated multiplication. Remember, if it's x squared, I'm only multiplying how many times? Twice, right? But if it's 2 to the x, it's multiplying by what? Not multiplying by x. If it's 2 raised to the x, what is it multiplied by? 2. So we're constantly and repeatedly multiplying by 2 an unknown number of times. Like it can change how many times we're multiplying by 2. So, guys, you got to remember this one. If I see x squared, what type of function is that? Thank you, right? We got to remember squaring is a quadratic. Like that's the kind of defining detail of a quadratic in an algebraic form. So, and also remember, we literally just said this was exponential, right?
Mm-hmm.
What makes it exponential? The x, or the variable is an x.
Square.
What's the thing called? That's b to the x. That's called n. The b, or is an exponent, right? Why do we call it an exponential? Because the variable is an exponent, right? Repeated multiplication. I'm glad we're recapping this really quick. All right. By the way, what do we call this b? What we're constantly multiplying by? Constant factor, right? What do we do with factors? We multiply them. All right. Quadratics. We're not going to review this quite as much because, well, we've been dealing with quadratics a good bit. So here's what we're about to do. Oh yeah, I wanted to talk about this one really quickly. How much did we talk about this problem on Wednesday? We talked about this one a lot. So f of x equals -2 minus 2/3 x. Okay, so what do we remember about this one? Concave down. Why do you think concave down? Good thinking. Like, let's keep that thinking going. I need y'all to look at this equation again, though. What did I just say is kind of like the defining mark of a quadratic algebraic? A square. Do we see a square up here?
No.
So is this quadratic?
No.
So remember, I'm not going to talk about concave down if it's not quadratic. What kind of function is this? Linear, right? Notice there's no variable exponent, right? It's just linear. How do we know it's linear? There's that variable of x and it's being what? Alright, so that multiplication, constant, and repeated addition. If you want, not if you want, one, I always recommend write your equation to kind of compare them. If you were to do a times b raised to the x, those don't look the same because that's a variable exponent. But I can very quickly flip this equation. And hopefully looking at that equation, we recognize what's the y-intercept?
It's a negative 2.
It's the negative 2. I just flipped the order. We need to recognize that the order was flipped. So the y-intercept is negative 2. And so what is this negative 2/3 right here?
Our slope.
Our slope. How do we calculate slope? Yeah, for those of you who said changing y divided by changing x, that's correct as well, right? That's better for tables. So I'm going to come back to that in a second. So that means I'm doing what? My rise is going to go down 2, to the right 3. Notice, if I see that, man, that makes things nice and easy. But do you have to go straight from an equation to a graph? No, what can you always create? A table. Do not forget, you can always create a table, because what is a table? It's just a set of, what do I call this thing? Which one's the inputs? The x is my inputs, the y is my, okay. Damon, what's a really good input to always start with? 0, right? 0 is a great one. Your x looks like a y. F of 0 is equal to, notice, what am I letting x be? 0. So negative 2 minus 2/3 times 0. And I will say this, on this problem, you would have a calculator. So that you can quickly check yourself. Notice, what's that going to become though?
0.
And negative 2 minus 0 is just, oh my goodness, you mean just like this is 0, negative 2 right there?
Oh my goodness.
That's wild. It's like it's telling the same story, just from different perspectives. Now, a lot of times we go by ones, and could you go by ones here?
Yeah.
100%. I wouldn't. Anyone know why? Say again. Not just because it would take longer. There's something about this equation that tells me not to go by ones. Well, I'm focusing on the inputs. It's the fraction. What does this fraction bar mean? Divided by. So what's a good rate to go by in the x? I'm going to go by 3s. It makes my life easy if I go by 3s, because I'm dividing by 3. There we go. And so let's say I substitute a 3 in. Well, 3 divided by 3 is just 1. What's negative 2 minus 2? Negative 4. Just like, I don't know, this 3 negative 4 right here. Wild! So inputs in, outputs out. Makes my life nice and easy.
Wait, is there one?
Yeah. 1, 2, 3. 1, 2, 3, 4. Yeah, still works. I substitute a 6 in. You know what 6 divided by 3 is? And so I get negative 2 minus 4, which is? You know what that point is? 6, negative 6. Inputs in, outputs out. It makes my life easy if you get stuck. Now, it could be easier if I just recognize, man, subtracting by 2, adding by 3. Change in y, change in x. If you understand slope as change in y divided by change in x, it makes your job nice and easy. And you can check it on the graph as well. Now, hopefully, with linear, we know how to make a graph right from the equation. But let's say you don't. Could you make a table first?
Yes.
Inputs in, outputs out. Right? So, keep that in mind as you're working through creating graphs and tables. Now, that's in contrast here to number 6. Number 6. To be honest, you can do it just starting with a graph, but it's a little bit harder with this type of function. What type of function is it?
Exponential.
Exponential. Does anyone know anything about this exponential?
No.
Nothing at all? What about the equation? What's the equation for an exponential?
It's a times b.
There we go, b raised to the power of x. So what's this a right here? Yeah, but what is that? If I recognize it as my y-intercept, that makes things easier. Now, Remember, you can always make a table. What's a great input to start with, Damon? 0, right? Does anyone remember what 2/3 to the 0 would equal? That would be 1. And what's 6 times 1? Oh, so 0, comma 6. That's my y-intercept. And then what am I doing to that y-intercept? Repeatedly what? Multiplying by what? Not 0, by 2/3. Guys, right here. 2/3 raised to the x, right? That exponent literally means repeated multiplication. Constant repeated multiplication. Now I can check that, because if I substitute a 1 in here, I get 2/3 to the first. 6 divided by 3 is 2, and what's 2 times 2? It's 4. And I could have, just because I have experience with it, taken that 6 and multiplied by 2/3 to know I was going to get 4. Then I'm going to take that 4. And so I can substitute 2 in now, if I wanted, but I'm going to make my life easy. I know I'm going to multiply by 2/3, which is 8/3. Now, you're like, Mr. Kinney, how the heck do I graph that? Just get the decimal version. It's 2.6 repeating. And yeah, I've done math for a long time, so I just knew that. Most people don't. Use a calculator. 2.6 repeating. Then I take that 8/3 and I multiply it by 2/3. And I get 16/9. And that comes out to be 1.7 repeating. And I take that 16/9. Multiply that by 2/3. 32/27. Yeah, I got no clue on that one. 5/27. I don't know. It's a little over 1. But you can start to see it create that exponential curve. And where is it going to level out? And get close to, but not touch. It's going to get close to the x.
Intercept. Axis.
X-axis, right? It's not actually going to get to the x-axis. It's going to approach it. And Ms. Kolsky did ask if I talk about why that is, and usually I do. And I'll just do a quick note. Please make sure you don't cross the x-axis here. There will be times when you can, but this is not that case. The reason why is, what am I repeatedly doing again? Multiplying by 2/3, right? And so this number is going to get smaller and smaller and smaller. We can already see that. But if I take a positive and I keep multiplying by a positive, what's it going to stay? It's going to stay positive. Will it get close to 0? Sure. Will it get to 0 though? No. Will it ever actually get to a negative? Definitely not, right? A positive times a positive stays positive. Okay? Alright, so let's do some review and practice and fun. It's time to play some Trashketball. So, the way this is going to work, you're already in your groups. Do we consolidate? No, I like these groups. And by I like them, I mean they're pretty filled out. So, in Trashketball, you're going to actually pull up Desmos. So one person per group does need an iPad. So pull up Desmos. Go ahead and log into Desmos. And with that, each question, you're going to, if you get it right with correct justification, not just the answer, because here, remember on assessments, it's not just about getting the answer, it's about justifying yourself and be able to explain yourself. That's 1 point. We actually changed it a little bit because I don't know if I just have a super unathletic first block or what, but they could not make a basket to save their lives. So we don't just have a short shot and a long shot, we actually have a short, medium, and a long shot. The short one is going to be worth 2 points. The medium shot there is going to be worth 3 points, and the long shot is going to be worth 5 points. So where it currently is, the trash can, that's the long shot worth 5 points. So if you get the answer right, you get it and justify it well, you get 1 point, and you can upgrade your point values based on how far away that shot is. Yes, ma'am.
How do I get to the thing?
You just need to go to our classroom. So log in under student. Have you ever logged in? You've logged into our class.
To the right there it says
Go to
student.
Student home. Yep.
Okay.
LEQ, Trashketball, review. So LEQ for linear, exponential, quadratic. Do y'all have an iPad? Okay, perfect. Alright, so I'm going to pull it up on Desmos. Whoopsies. I want to show you the first question.
You don't have an account. We can get you a code. Mr. Manning, do you mind popping up the code for Jeremiah?
Yes.
And Alex?
Okay. Hold on, I gotta do the classes. Can you write this over there? Or, here you go, Jeremiah. There you go.
Oh, thank you. Is it because I keep back in a skirt?
No.
Oh,
I actually liked your pants. Your sweater lines though.
What?
Like your last sweater, like the lines going.
Oh, my mom gave me that sweater.
It's pretty, but.
It's on my mom to it.
I'm gonna tell my mom you hate
You
it.
call her after school.
All right.
I hate your sweater.
And that's gonna just make her
Type
sad.
in student.desmos.com.
And you'll have to make an account. Because I don't think you have an account yet, Jeremiah, do you? Okay, let's do this. While they're making an account, we'll go ahead and do the first question. Or did you log into yours? Okay, perfect. Oh, how did Lily's even pop up there? You let her use your iPad? Got it. We need to make your own account soon. Okay, go ahead and hit start. We'll just go off of that. Huh? Yeah, the LEQ Trashketball review. That's linear, exponential, quadratic. All right, is everybody in? I got 2 groups in. I need a total of 4, because we got 4 groups. Has everybody clicked start activity? Okay, you're still logging in? Tori, you still logging in?
Stop cheating.
Okay.
Okay, I didn't do it.
All right. While Tori's still logging in, let's go ahead and get started a little bit so we get some experience with this. You might, if you want to go ahead and answer it based on looking up here, you can, but there's later questions where you really want that iPad to make it easier to see. Go ahead and erase the board, so go to your vertical surface, erase your boards. Y'all have one. Hey, Shantae, you want this? And Tori, you have an eraser. Okay.
Work on the white book. Later.
All right. First question. Please be careful. Pay attention to the directions. First question will now appear on your iPad. It's also up here. Identify each type of mathematical representation. Make sure you are ready to justify. Ms. Kowalski or I will declare a winner when we are here. Solid justification or see it.
What did we say? Graph.
Don't be cheating.
Actually, we'll just talk.
Talk about. Okay. How do you know? How do you know it's the first one?
Graphical,
How?
because it's using the graph here, and it has a curve, and then algebraic, because it has an algebra form, right? So it's basically like, X equals X2.
I know, but how does that tell you that it's algebraic? Like, what is it?
Basically, it's in a form of an algebraic.
Getting their justification.
Okay. Okay. So standard form. Oh, kind of accept
And
that.
then tabular, because it's in a table, like it's going 1, 2, 3, and it has inputs and outputs.
Okay. There. I'll take that. All right. We got a winner. They started explaining it. They were already explaining it before y'all had your answers up. So I let them continue.
Okay, yeah, sure.
But listen, there's only 2 of us. They had their answers, were able to start explaining it before you had your answer up to start explaining it to me. So whoever gets their answer up and can explain it. Or an alternative is, and you may want to consider this, an alternative would be you writing your justification up there as you work through it. Then we don't have to come over and listen to you explain it. We can just tell whether you got it right or not. Why'd you erase it? Okay.
Sorry.
No. Okay, but let's talk about a couple of things. I want to point this out and I want us to be more clear. So why do we know that, because y'all got this right, why do we know A is graphical?
There's a graph.
No, it has what? has plotted points on there. Does anyone know, by the way, what this grid thing here is called? Does it start with a what? There's lots of different things you could call it. There is an axis of symmetry. That's not what the grid thing is called, though. Okay, so the most common name for it is a coordinate system. Coordinate system or coordinate plane. And why do we call it that? What do we put on the coordinate system? Coordinates, coordinate points, right? So why is it a graph? Oh, because it literally is a coordinate system with points graphed on there, right? So going a little bit deeper, I want us to hold on to these details. How do we know, and you and I accept it, but I need a little bit more, that there's a plainer way to say it. How do we know the second one is algebraic? Yeah, but what algebraic expression? There's three different real options for algebraic.
Oh, it has to have a slope in it.
This one's like quadratic for function.
There's three different types of algebraic
An
representations for the...
exponential, equivalent.
You're a what?
It has to have an exponent, equation, expression.
Expressions, equations, and inequalities. Guys, the foundations for algebraic representations are expressions, equations, and inequalities. An expression is just this. That's an expression. Why is it not an equation? It doesn't have an equal sign. As soon as I say it equals f of x, it is now a what? An equation. Or I could say it equals 8. That's an equation. Let's say I change that equal sign to a less than. Now it's an inequality. So our algebra are our expressions, our equations, our inequalities. And then you like what you said at the end there was great for the table. Why? What was the last little detail you said for the
It
table?
needs to have an input and output.
Right, it's that set of inputs and outputs, organized inputs and outputs in a table. That's what makes it tabular. Okay, so good on identifying them, but let's also work on justifying them. And sorry, they just started explaining first, I had to let them finish explaining. But if you want to write your justifications up there, I can look up while people are explaining. Why
I
not?
was explaining.
Okay. Okay, cool.
Take a shot. You want take a shot?
Oh yeah, take your shot. Or Tori, if you're feeling good about shooting, you take your
You
shot.
want long, medium, or short shot?
I want to medium.
Do
Okay.
medium?
So you, oh no, no,
you
you
shoot
shoot
from
from
back
back there. And this is to the medium.
You just crumple up a piece of paper.
There's paper in it, yeah.
This is so wasteful.
Yeah, this is really wasteful.
What about the
I
trees?
mean, I don't care about that.
Why don't you guys use like the same paper?
Call Delora.
Never mind.
You want a short shot?
Wait, how many points do I get for short?
Right, 2. It's a 1 point difference from 2 to 3.
From here?
Yeah.
Oh.
No, no, no.
No.
Oh, wait,
From
okay.
there,
From here or here.
that's 2 points.
Okay, I'll just do that one.
Okay, this one? Oh!
Stop.
So close. Alright, so the 8s are on the board with a point. Y'all ready for the second one? Raise your boards. Get set. Erase that right there. 3, 2, 1, blast off! Which of the following relations are functions? Make sure you justify, don't just write answers.
You can get sick,
Out of the way.
Yeah.
Make sure you justify why.
Then what would you?
I've heard answers. You and Tori, make sure you're talking with each other. I'm gonna start asking Tori to justify it in a second. So I heard both of you talking about it. Let's look.
Oh.
And you and Allie as well. Need y'all talking. I need y'all learning together, not just trying to win.
Okay,
A and R.
sorry.
Okay, why?
Okay, so A is a function because it represents a quadratic, or quadratic form.
Okay,
And then O is not because it's not either, it's not a linear, an exponential, or a quadratic.
okay,
And then R is a function because it represents an exponential.
okay. You're kind of on the right path. However, I will say this, linear, exponential, quadratics are not the only functions that we have. So it's not just that one is not a function because it's not linear, exponential, or quadratic. And there's other things you need to remember about what a function is.
How does it make sense? I'm not getting it.
You say you really just do this?
Well, I mean, I kind of knew like why, but I just never know how to form words.
There's a definition that tells you. You have to go back to those definitions.
Oh.
What about O though? What about O? Is it a function? Why not? Better justify it.
Are you done?
Okay.
Yeah? I thought-
Girl, right line.
I think we might.
No.
It's like spaced out, but.
Alright, we do have a winner. It is the nines. Let's come over here. Let's talk about it. Is the camera still recording, Ms. Kolsky?
Yeah.
Can you just hold it this way?
Yeah.
Alright, so let's look at this. I need y'all
Yeah, it doesn't.
paying attention. Because it's about the what? Vertical line test. Now, I'm going to talk about some more details in a second. But A and R, when I look at those, do they pass the vertical line test? Yes. Okay. But O, the circle, does not pass the vertical line test. That's some good information. There's a little bit more that I want to push on. I'm going to bring y'all over to here to talk about it. So, can y'all come walk this way, get closer to the action? So first, I want to point out what Jeremiah said. He said, this has a parabola which shows in quadratic what? Quadratics are what? So like, could you have said that A is a function because it's a quadratic function? Yeah, like that's true. R is an exponential function, right? There's an exponential curve. But there's something more that I want, because y'all were talking about, the circle is not linear, exponential, or quadratic, right? Which means it's not a linear, exponential, or quadratic function, but that's not what makes it a function. Because I'll point this out. Is this linear, exponential, or quadratic? No, that looks nothing like anything we've studied so far. But is it still a function?
Yes.
Yes, how do we know? Because it passes the vertical line test. However, I just want to remind you, what is the vertical line test? Because what it is goes back to the definition of what makes a function a function.
It can be lines passing
Remember, the definition of what a function is, each input maps to one and only one output. This vertical line has how many inputs? Now, how many inputs? That has one input. How many outputs do we see? I'll say, how many times does it hit the function? Once. So how many outputs does it have? One. This input has how many outputs? One. This input has how many outputs? Right. So that vertical line test is just testing, does one input map to only one output? It only intersects once, so it's a function. Whereas here, how many outputs does this one input have? How many outputs? That one has two. That vertical line maps to two outputs. So that one input has two outputs. That is not a function. Does that make sense? Does that remind us of some important details? All right. Who needs to take a shot? Nines do. Caleb, you got volunteered. There's a sheet of paper that's already crumbled up over there. Turn it on, Caleb. He remembers math, but whew,
What kind of
really to
shot?
see a wadded up piece of paper. Hey, did you want a short, medium, or long shot? Okay.
You gonna pray about it.
Might want to let someone else shoot it in the future.
Hey, okay then.
All right.
And you were talking about.
Raise your
Hey,
board.
hey,
Raise your board. Raise your board. David, don't write on my zombie math poster. Thank you, sir. Erase your board. 3, 2, 1, blast off! Which of the following relations are functions?
Okay, you got that. Okay.
It's not right.
Allie, you enjoy my any thoughts?
We have two inputs.
And Brad wasn't in his office earlier, so my guess is he's out, so you want to go to the GPA? What time is it out?
Starts at 3.
No. So leave it 2:15? That give you time to park and walk?
It's at the library.
Oh, so you can park right there.
Yeah.
So 2:30?
Yeah. She was this last time. Do you want her to email you?
Are you gonna do sketchy things and bring
No,
my
she
trust?
just asked last time. She's like, there are some mentor teachers that don't trust them.
Yeah, I'm good. Done.
We're done. We do not have a
We
winner.
don't have a winner.
Oh my gosh.
Anywhere.
No
Nowhere do
winners.
we have a winner.
Y'all need to re-examine. No winners.
Oh, that ain't playing on winning.
Oh, wait, what?
What you Is it the reason or is it the answer?
Can't tell you that. We do not have a winner.
Well, I think you could do it for the sake of-
Wait, how did the Nines already have 2 points? They missed.
Oh. Miss Kayla.
She knew
She's trying to
She knew I was
cheat.
gonna make that. She knew I was gonna make
Okay, so is it?
that. You knew I was gonna make that.
But you didn't make it. Oh, is it?
Y'all fix your answer.
Our answer is like,
It's wrong.
It is not.
It's not wrong. I don't see it.
We know B. Couldn't the second one.
Because they're both up there. Yeah, at some point on the board.
No, outputs can be the same. It's just the inputs can't be the same. No. The middle one is correct.
wait.
It doesn't have a zero though. It doesn't have a Y. Wait a minute. No. Second one.
Okay, we only have 1 more minute till we go to lunch, so I need y'all to actually come up here and learn from this one.
Okay.
What makes a function a function? What makes a function a function? One input maps to one and only one output. Here's the issue. I designed this question to test your actual understanding of this. Y'all are all saying the second one is not a function.
It is.
What does -3 map to?
15.
Does -3 map to anything other than 15?
No.
So one input is mapping to one and only one output. What does -2 map to?
4.
Does -2 map to anything other than a 4?
No.
No. So one input is mapping to one and only one output. So the second one is in fact a function. It's a very important detail to pay attention to. Notice you didn't have to worry about that in the first and in the third because we didn't have any repeat inputs. Right? 0 maps to 0, 1 to 1, 0 to 0.301, head on to.
What about those CCC pluses? Something required. Let's see.
I gave Miss Kay.
This?
We're done.
Yeah, just 5.
Well,
Okay, so
you
the
can
first
use that
one,
for A2, but
it
You
shows
can
a
repeat.
parabola.
Okay. Yep.
And that goes in our quadratic system. And the second one is a quadratic, this is our like formula kind of for using the formula.
She knows what we mean, but like,
Be a
she's
little
just trying to,
specific,
yeah.
Like,
which,
I need more.
yeah.
it's our, it's the quadratic, like,
Equation.
yeah, equation.
I need more. I need to know how you know that.
How do you
Because,
know it's a quadratic?
because quadratics have, the square.
Okay, move on.
And then C, it's linear because it's, multiple additive. Am I saying that right? I don't know.
Multiplicative.
No. Which one's that, Damon?
That's exponential. Yeah, this is a repeated addition.
Done.
Anita.
We got a winner.
Constant.
That constant is so important.
It's the everybody's the
Yep.
same.
What'd you say?
Repeated. It
I
is.
did,
She
I
said,
ain't
she said
So-
repeated addition.
Yeah. All right. Let's talk about that. So I'm going to talk about these answers in a second. I need y'all to see
He
this.
just said no.
Okay.
Literally, it's.
So I need. It's not, and it's important to understand why it's not. Okay. So really quickly, first off, why do we know B? Actually, I'll just use that equation. Why do we know that B is quadratic? Okay. There's something else, and so you are correct. It has not square root a square, right? Remember that standard form clearly shows that square in there, right? Okay, so what I'm going to quickly do is I'm actually going to make a table for this quadratic so that we can understand why we can't just say it's repeated addition. Now, first things first, does anyone know how I could find a good starting point? Because I would not use a starting point of 0 here. That's good for linear and it's good for exponential. But what's good for a quadratic? Kind of where should we kind of look for our quadratic starting? Y-intercept could be good, but notice that vertex. Remember how there's symmetry around that? Anyone know how I might find that line of symmetry or that vertex from that standard form? There was an equation we learned. Opposite of B divided by 2A. Remember, that's how we calculate what H is from our standard form. So negative 2 divided by 2 times 2. Nope, 2 times 1. Why don't let me make that mistake? And negative 2 divided by 2 is what? Negative 1. So I'm going to start with a negative 1 as my center here. And how am I going to find out the points for this quadratic? I'm going to substitute it in, right? Inputs in to get outputs out. Now I'm going to speed this process up just a hair. So 1 minus 2 is negative, so 4. 4 minus 4, so 5. And that makes sense because that's 5. 1 plus 2 is 3, so 8. Okay, so here, that is the table for that function. Now let's look at our rate of change here. This is what I need you to pay attention to. What? I need something other than a purple. That'll work. Do you have a color other than purple? Thank you. All right. So right here, what's happening to go from 8 to 5? Minus 3. 5 to 4? 4 to 5? And 5 to 8. Notice that's repeated addition. It's not constant, but that is some kind of repeated addition. It is addition every time. Even minus, subtracting, right, is a type of addition. It's just adding a negative. But this is adding 2, adding 2, adding 2. What does it mean to be constant? It means to stay the same. So we can't just say it's repeated addition. We need to be clear that it's constant and additive. It's repeatedly adding the same amount. And what have we always said is to the left of constant additive? Why did y'all say that was linear? Because at what type of rate of change? So what's always to the left of constant additive? Linear. And it's a linear additive rate of change, okay? So it's important that we understand that before the test. It has a linear additive rate of change, and that's a type of repeated addition. Now I will say this, is that the only way you could have justified that C was linear? What else could you have done? You could have written the equation, that I would have accepted that. What else could you have done? Not what I'm doing right now, but what could you have done? You could have made a graph, right? Notice, literally, when I make a graph, what does that look like to you? Really bad one, but a line. Thank you. Thank you. Okay, so please pay attention and note that. Does that make sense though, Jada? Just so we know for the future. All right, so 9s, you get a shot. What type of shot you want to take?
The big.
Which shot? Short
How's
shot.
that? I don't know that Caleb's group wants to see Caleb shoot again. What?
Actually, they did. They nominated me again. But I declined.
Oh, is that what happened? Scott, is that what happened?
Decline.
You can adjust.
No, oh, you didn't even get to see Caleb shoot? Oh, you missed out.
That.
It was a fantastic shot.
Right.
What you doing?
He's on the line.
You ahead of that line. Back up. You gotta be behind that line. They didn't allow that in a free throw.
You just said behind that head. Let me see.
Bro.
Oh.
You would have made it if it was.
Okay, yeah.
Alright, so the 9s are at 2. Were the Jacks not at 2?
So let me do.
Jack-
Oh, they didn't have any
They didn't
points.
have any, but I gave him one because.
Got it. Okay. You all ready for the next one?
Wait. You gotta get your legs.
The Kings got one too.
They don't.
3, 2, 1, and blast off.
Blast off, y'all.
Y'all better blast off quick. Hey, Miss Paulsky, come here real quick. Just so, because I've been meaning to show you this. You know that you can zoom in by doing this, right?
Yeah, I thought I did earlier. I didn't
Okay.
know how much you wanted in it though.
Just so that you can at least see the screen clearly. Does that make sense? Yeah. Just because it's too zoomed out. It was zoomed out a second ago. You just can't see much.
Whatever, B, C, M.
There's a few ways you can figure it out. Honestly, you can just keep staring at it. It's not going to pop in your head. What did you do to figure out? Y'all stare at it on a test like this, you're going to be in a world of hurt. You got to figure out what you can do. I will say this, Tori, you might. What are you trying to do on that?
So there's exponential.
I mean, here's the thing. Can you write the numbers next to the table or trying to figure out what's going on?
Yeah, it would
You can do that. It might be helpful. There's other things you can do though.
be Miss K.
No.
Tell us why.
No.
One.
Who say no?
What are we missing on?
Why for each of them?
Okay, quadratic because when you do the math, it has like an x squared.
Okay.
Second one is exponential because our table is showing that that constant multiple.
Multiplicative.
What'd y'all erase?
And then our third one,
No.
We did a graph. We erased it.
Why did you erase it? I don't see any evidence.
He talking to you, man.
no,
Y'all better get some evidence. on
What
it.
can you do? Try to figure that one out. What can you do?
Okay.
What's going on?
I want to think about that.
But then what about to go from 0 to negative 1?
3, 4, 1.
Minus 1.
It's not.
You're going from
You got it. You got it.
the plus 1 here. In between.
You got it.
Alright, we're done. We have a winner.
Thank you.
That's
Who's the winner?
Oh, that is right. Okay.
Hey, we got the arrows.
It's all. Alright, so I do want to address this. First things first, if you are looking at a table, can you make a graph? If you're stuck looking at a table, can you make a graph? 100%. However, guys, if you're looking at a table, what should tell you what type of function it is? The rate of change, right? Look. So this group started it. I wish more of us had done this. To go from -1 to 0 is +1. What about to go from 0 to -1? -1. -1 to -4? -4 to -9? Notice there's nothing constant, additive about that. But what about to go from 1 to -1? -2. What about -1 to -3? What about -3 to -5? That's constant additive. So what does that make this rate of change? What's to the left of constant additive? Linear. But it's not a function. What are we doing with this linear? We are adding. It's linear additive rate of change. And that is the telltale mark of a quadratic. What makes an exponential exponential? Constant repeated multiplication. So it's not exponential. All right. I do like that y'all noted. How did we know that h was quadratic? That's that factored form, right? A times x minus r1 times x minus r2. We got to recognize that factored form when it shows up. And I see that, I think everyone said exponential for the second one, right? But constant multiplicative, what rate of change? What are we constantly multiplying by? 2. Okay. So that one's an easy one. And there will be on your test some easy ones to identify a constant factor. But don't forget how to find that constant factor even when it's not easy. We'll look at some examples of that. All right, erase our boards. We're going to go to the next question.
We gotta shoot.
Oh yeah, we got to shoot. Someone erase boards though. Caleb's going to try to go for redemption. Come on, Kings. I know y'all know this stuff.
Look away.
I want the next one to be y'all. Damon, you do know this.
No, we do.
Nice.
All right, 2 more points to the 9s.
Look, y'all, you get one, you get the long shot, you're in the lead.
Oh.
Throwing
Yeah.
that out there.
I have faith in Damon's ability to at least hit the median.
Same for y'all. You get one.
All right, next one in 3, 2, 1, blast off.
Nines, I want you talking. I don't want just one person doing it. You're
That's
not
not what I
talking,
see.
right? I don't hear nothing.
Can you justify it,
Yes.
Ms. Wolski?
Okay.
Just fine.
So we found our y-intercept first,
Okay.
which is
Can
0,
you
2.
justify it?
Okay.
And then
What is that though?
that's our next. That's just the
We got a winner.
Good job.
Mr.
Commissioner.
They got a point?
Yeah, got a winner.
We got a winner! Can you put my piece of chalk back? Okay, so I need us to look at this one really closely. Alright, I want to point out, so I know, Jeremiah, you were writing an equation over here, but I want y'all to pay attention to what we have over at the 9s. What was the first thing the 9s did? They wrote y equals mx plus b. Guys, as soon as you know it's a linear function, which, how do we know it's linear?
It's a line.
What is it? I need more clear language. If you're ever using the word it, that's not clear.
Linear
The
line.
graph has a line. Okay, so we have a line as our graph, y equals mx plus b. Write that out to help focus your attention. Remember we talked about this equation earlier. What is the name of this equation? Slope-intercept form. Because quite literally in that order I have my and y-intercept. And so I noticed you started with that 2x, but are we repeatedly adding 2? No, what is that 2? Y-intercept. Notice if you write that equation out, that makes it easier to access and say, ah, there's my y-intercept. Next piece, what about m?
Our m is -3.
How'd you get that though?
We started at 0, 0, and then we added our y-intercept to whatever. Forgot our explanation. What was our explanation?
They explained it, I
We
promise.
did. I just don't even remember what we said.
You guys know how to do this on your test though. How we calculate, what is m? It is our slope. How do we calculate that?
Change in y over
Change in y divided by the change in x. Now, I will point out, there's another way to do that. Shantae, what's the other way to write that? No, you just, why are you erasing that? You read that out loud, what you have. Rise divided by run, oh my goodness. So, please remember, the rise is the amount of change in y, the run is my change in x. Now, so you can go from here, and note you could go down to, nope, not down to. I know some people try to go to here. Notice you don't know exactly what that point is. You need to go to this point, which is down 3, to the right 1, 2, 3, 4, 5, 6, and 7. So that is -1, 7. Or you could have gone up to here, up 3, and to the left 7. Notice 3 divided by -7 is the same thing as -3 divided by a +7. Either way, you would get this equation. Now, one thing I want to caution you based on what I saw the winners do is, y'all wrote the -3, which I wish you hadn't erased it. You wrote the -3, 7, but what is that? A point. Do we have a -3, 7?
Sorry. Yes, sorry. I was rushing. I was like freaking out.
I know. But be careful, right? That -3, 7 is not a point. If you want to label it as maybe our rise and our run, or the change in y and the change in x, just please don't write that as a point, because it's not a point, okay? That's an easy way to screw things up. Alright. Y'all ready to shoot? Yep. What y'all gonna shoot for? Longest! Oh man.
Oh my
We
God.
got a
Gotta
whole
make
loop
this, we
time.
only get 1 point.
Girl.
That's a long way.
And they get 5 points if they make it all the way there.
Oh.
Go long. Yes. Okay.
What are you talking about?
Next round. Let's keep it going.
It's good to be conservative sometimes.
In 3, 2, 1, blast off.
That's true.
So what's going on over here? I see people individually. What are you doing?
Oh wait, is it going by 2?
Huh?
By 2?
It's what? Okay. So what are you gonna do from there?
Oh, so the constant vectors. That.
Yeah.
So it would be.
Okay.
You have it written on there. You have it written on the board.
I guess that's how you define the constant factor.
Think about that setup.
Say it again.
Times.
That might be a good strategy. Keep thinking about it.
Have a winner.
We have a winner!
Well, you guys went.
Do we have a winner?
Yeah.
Yeah.
And I heard them talk about it.
Yeah.
Alright, I need to caution y'all, and I want to point this out. So, there's a lot of y'all that had a lot of good ideas going from the beginning. And Jeremiah, I'm going to talk about something you said because I really liked it. But I want to encourage the Jacks to notice, wait, stop erasing it. We're about to talk about it. Okay. What I want to encourage y'all to do is to remember your other mathematical representations. Yes, we're trying to write an equation. Yes, I know most teachers say, hey, you just have to look at the thing and know what it is right away. However, you don't here. Make a table. The table is a great way to find the what? Starts with an R. Rate of change. The table is a great way to find the rate of change. Slope is easy enough to find on a graph. But you don't want a slope here. Jeremiah, you said it perfectly. What are we looking for with this exponential? A constant factor. Remember, exponential, we want a constant factor, right?
I mean, yeah, everyone knows I used your bracelet.
No, we haven't written this one.
If you identify these points, look guys, okay, right here. It's not easy to just look at an exponential graph and know what the rate of change is, but what's happening? You go from 2 to 6 to 18. 2 to 6, 2 times 3 is 6, right? 6 times 3 is 18. Just looking at that graph, you're not going to see the constant factor. Writing out the points though, that's a game changer. Okay? Writing out those points is a game changer. Making it into a table. Now, I do want to caution you, looking at this table over here, no, don't erase it yet. Learn from it. Hey guys, how do we read books?
Left, right.
From left to right, right? Okay? How do I read a graph? From left to right. Notice when we go from left to right, we're going to say from negative 10 to a positive 10. We want our x's to increase. Notice how you did your x's backwards, so it decreased there. That way it actually looks like your constant factor is a 1/3 and not a 3. That's why we want our x's to increase to 6 and 18. Now, last thing I want to point out, I need y'all to be careful about this. Notice when you do it this way, it's much more clear. Times 3 times 3. Caleb, part of the problem that you ran into, you put negative 1, 1. But if you look closely, is that point on the intersection of that coordinate grid?
No.
Based on the way I asked the question, the answer is no. But just looking at it, if you put 1 here, is it 1 times 3? No, but clearly it's times 3 the rest of the way. It was actually a 2/3 times 3 times 3 times 3. So be careful, do not use a point that is not perfectly on the intersection of the coordinate grid. Does that make sense? Okay. I'll answer the yes, ma'am, it's whatever.
No.
Okay. Ready for no, we still need a shooter, right? Tell you what, those Kings coming in strong, we gotta pick it up.
Again, or you?
Yeah, we
Who? Going long again?
No.
She
Got
knows.
it.
She knows. She knows now.
Yeah, you got it now.
So I'm gonna risk it for the biscuit.
See, why did you start singing?
That's
his fault.
Hey, whoa.
That wasn't me, that was Caleb.
This was the love.
Ready?
That's fine.
Raise your boards, 3, 2, 1, and go.
Hey, and we done
Ready
the
for
other
the
board.
construction. Oh my goodness. Wait.
Yeah,
Okay, but
Hey, instead of just trying to do it in your head, what could you do to make it more concrete and easier to see?
Yep. That's linear.
But what could you do to make your life easier?
what is it?
Yeah, that's.
Okay, slow yourself down. You want to use the lines that are on that grid.
Oh yeah, I forgot.
Oh yeah.
Well,
mean, you gotta do what you gotta do.
Gotta do what you gotta do, I get it.
How confident are you in that equation?
Ooh, 4.
Any idea where that equation came from?
Ooh, I already got it on a graph, you need that right.
Are you talking to your group now?
Okay.
I know it goes,
Say again.
Okay.
Okay.
it's over
So
here.
it's tracking my 6 going down? Or like that?
Mom, you don't have that many squares.
What else?
Look, it just goes like that.
Okay.
Ain't nothing negative, so it's there.
It eventually goes negative.
Yeah, it goes down here in this one.
No, there's a way to write this that like
So you're thinking that equation's right? I'm gonna point this out.
Can you explain to me?
Let's say
Because
I had
everybody knows
two
that, writing the
Three
equation.
times
No,
four is
that
36,
21 's
36
the
minus
origin,
6 is 30.
21 's like right here and.
Wait,
We're
the
not giving me the right outcome.
I'm so stupid.
Hey, if I were y'all, I would slow down
Wait,
and
is
I
it-
would do the
is
thing
it
I
Y
told y'all and I told you since the beginning first. Look at maybe the hint of what some of the groups did as the very first step that they took.
3x
That's
plus.
the first thing you can do.
I'm gonna find the freaking. Oh. Okay, so
Yeah.
8.
6.
I'm gonna do
No, I
these.
don't know.
Shush, please. Sorry.
Hey, what could y'all do to make this easier other than just like kind of staring at it? So like graph, you can make a
No.
table.
It's like 6.
What I would also do
I was
is,
4. 6.
This is not Allie Parker.
It's just 6. I'm just.
she's on her way.
It's 6.
Make sure you're studying, Allie. We got stuff that you need to do.
Hey. Give me some man. Wait.
Hold on.
Stop! You're freaking me out with day.
Wait,
Is this right?
36.
No.
Oh my gosh.
Nah.
Like, write that equation out. And then you should know, what does this mean? What does this mean? Because you're just looking at this and assuming those are the like,
Look at your table.
you need to think
Six,
about how it
six,
is
six.
and what this is.
6.
Talk about it.
Is it not
6
going
again.
down?
It's minus 6.
Yeah, but if we're going back up to 0, it'd be plus.
Well, just put 6.
We're already going
6
there.
on
We
one
have
and
to go
then
back up
positive
to
6 on the.
0.
Just write the question 2 times. And just put negative 6 and positive 6.
No, because only one of them is right.
Alright, well then he writes the one that she said wrong.
And go outside of those 5
I'm so confused.
Then do it.
So wait, if this was it, wouldn't it be negative?
Put negative, yeah. Yeah, it's going down.
Where's the Y?
Wait, on my graph it's going down. Oh, no.
Okay, so to go back
That's a
up
lot.
to
But
0,
y'all worry me.
we have to subtract from x. But
Yeah.
add on
Oh.
to y. I'm so confused. Wait a minute.
Hey guys, can I just make one quick note?
No, just gonna embarrass us.
No.
Just listen to your partners.
I don't know about that because I haven't been over here. But have y'all taken the time to write out what m is equal to?
Nope, ain't done that.
Wait. Huh?
Wow.
Think about your formulas. Think about how you calculate things.
It's probably got something to do with the
I'm stressed out over here. I feel like my blood pressure is rising.
slope. Yeah, they're struggling too, so we good.
Okay, wait, what did he say?
You could. Why make
What
you do that?
is slope? Think about that and write it out.
It's your rise over height.
Okay.
Is it 4?
What's up, Chloe?
Oh wait, so it's no, it's your rise over
Damn,
I'm so.
Give me a second.
So that.
3.
You're not supposed to be taking.
So it's not
3. Wait.
negative 6.
Alright, is it?
I'll wait.
Because it's a 5. This is
Yeah,
going
I
up.
don't think this. I got you. I don't think this right.
Confused. No, wait, hold on. Never mind.
No. Not.
No, I know. It's just like this is so much easier if I'm like sitting down myself. And
You need to not be in control and listen to your group.
I'm listening.
I can't.
Well, I don't know, see?
The only thing I'll say is this, remember, This input should map to this output, right? If you still see 9 into
Come on,
there.
we're done anyways.
See, I'm trying to listen to them, but we're not.
No, listen.
Our brains are not in this right now.
You're so close. But remember, this input needs to
Okay,
map
let's
to
just
that output,
start
right?
everything over. Okay, we'll redraw this table.
Okay, so remember, you identified with this one, you like all line intercept, right? What is this thing? But go ahead and get something critical, a super small but important details on what that thing is.
2, 8, 14.
Oh, no. We didn't have
Okay.
Y'all,
This
this
is,
is this stuff.
and this is minus 6. But we're trying to find a lot of stuff because our thing is,
What is this?
or at least I think, it's
You're trying to write the equation.
less
You know that, right?
We got a winner.
Slow down. There we go. Alright, I need y'all to walk up this way and look at it. Because, right here, okay, so, Jeremiah, you explained to Ms. Kowalski, I did not hear it, but where, and so guys, I need y'all walking this way. Where did your negative, so we all got the 38, didn't we? Yes? Okay, so we needed to remember, and I will say this, I cannot prompt you this much, like on a test, you gotta do this. As soon as you realize it's linear, what should you write out? Y equals mx plus b, right? Tori, what is that b right there? Because you said the y-intercept, right? Now, you knew, because you said, do we need to keep going? How did y'all know we didn't have the y-intercept to start? There wasn't a 0 in the x. Remember that y-intercept, the x has to be 0. So you can work backwards. 6, 3, and 0. So 26, 32, and 38. So many of y'all are trying to do this in your head. Quit doing that. Math is about problem solving and critical thinking, and writing the stuff down can be really, really helpful. And maybe show our partners where we're getting our answers from. Write your stuff down. So, y-intercept 38, cool. How in the world did you get negative 2 though? Because I got 6/3, y'all had 4/3.
We had negative 6 over 3.
Yeah, it was just in his head though.
Yeah, we had
So-
negative 6.
Negative 6 divided by 3. Caleb, did y'all take the time to put minus 6?
We did, but then we erased it because it was a lot of fixing to make sure.
But do you need that negative? Yes. That one small difference there. So negative 6 divided by 3, because that's my change in y, and that's my change in... I would have accepted negative 6/3, but you cannot, let me repeat this, you cannot do 6/3, because that's a positive, that's an increasing slope. Any questions about this one? Alright, we're going to do one last one. Not all the way, because we only have a few more minutes. But
Add 6 to go on.
one more in 3, 2, 1, blast off!
That's why we write tables
Nope.
from lowest to.
Blast off!
Better off in seconds.
Straight up. I thought we were going to get much further than this class. I did let them warp longer on this. Huh? Jeremiah, don't forget we got to shoot after this.
Shoot.
Is that not the vertex tool?
We don't know what we did, we know it's pop.
Yeah.
Shante, you need to be able to explain this in a second. I'm not letting y'all learn it if Caleb's the only one who knows it.
Okay. And then 8 plus H and B is
They're laughing at us. We gotta use it.
We're laughing with you.
No, laughing.
No, I'm not laughing with them.
It's really happening.
Ms. Kowalski is very liar.
Can't help it. My fault.
You wanna fight this guy?
Oh, I think you're right.
Let's go.
No, I think I'm okay.
Let's go, let's go.
Do your problem.
I'm letting you do it.
Alright, Sean,
I'm
say.
thinking.
So pause. Explain to me, where's
Cause
this?
you gotta change it, that's what you should have known. Cause we just don't know what it is.
But thank you, how did
That's
you
what
get
you was
plug in?
I did.
No, you plug
Then I
it.
can't let you learn credit. I was gonna let you learn your credit if you could explain it.
For A.
No, that's in today. Plug this in for
Yeah.
for the Y.
For A, birthday.
I think, I'm pretty sure that's how it goes.
What do y'all think?
I think that's Y is A.
Alright, I gotta pause y'all. We're almost there, but we have 2 minutes left because I need to talk about this one a little bit. First off, I will go ahead and say this, Ms. Kowalski, I did decide first block that we are going to let y'all continue reviewing on Monday. Test will be on Tuesday, but y'all need to take advantage of the weekend to look at those check your understanding questions and those Frere models to master these ideas. Remember, the videos are online. Now, really quickly, guys, right here. Please be cautious, be careful. So Jeremiah, y'all start with standard form. What's the only form we don't want to start with? You don't.
We should get to bathrooms.
It's hard to start with standard form. I was saying you tried to, and it did not go very well. Did it? But it's R minus R1 and X minus R2. What is this R2 here? What's that root? Yeah, but what is the value? It's 5. Well, 5, 0. What's this R1? 1. And so, if you're writing that equation, it has to be X minus 1, X minus 5. Remember, when it's X minus R1, it's the opposites. We didn't have time to find the A, so I'm not sweating that, right? But it's X minus 1 and X minus 5. Now, over here, y'all are using the vertex form. But guys, the vertex is H comma K. That's not my X, that's my H. Y and X are variables. We have to identify another point to substitute in for X and Y to find A, okay? Please practice these, check your understandings. I will post the Frere models on Schoology so that you can see them there in case you lost yours. You are all capable of mastering this, but you gotta put it in the time.